Welcome to Indian Oil Corporation Limited. Introducing you to the production process of new LPG cylinders manufacturing. Statutory requirement: LPG cylinder is manufactured for storage and transportation of liquefied petroleum gas of nominal capacity exceeding 5 litre up to and including 250 litre water capacity in welded low-carbon steel cylinders. The manufacturer needs to obtain the Petroleum and Explosives Safety Organization approval (PESO) as well as Bureau of Indian Standards license for manufacturing of LPG cylinder as per IS 3196 Part 1. The cylinder dimension and critical parameters are well defined in the system. Design code IS 3196 Part 1 2013. Working pressure 1.66 MPa. 16.87 kg force per square centimeter. Test pressure 2.45 MPa. 25 kg force per square centimeter. Working temperature ambient. Water capacity for a 5 kg cylinder 11.7 liters. Variation limit plus 5% to minus 0%. 14.2 kg cylinder 33.3 liters. Variation limit plus 3% minus 0%. 19 kg cylinder 44.5 liters. Variation limit plus 3% minus 0%. Inner diameter for a 5 kg cylinder 270.0 mm. Variation limit plus 1% minus 0%. 14.2 kg cylinder 314.4 mm. Variation limit plus 1% minus 0%. 19 kg cylinder 330.1 mm. Variation limit plus 1% minus 0%. Total cylinder height for a 5 kg cylinder 370.0 mm. Variation limit plus 5 mm minus 5 mm. 14.2 kg cylinder 625.0 mm. Variation limit plus 5 mm minus 5 mm. 19 kg cylinder 725.0 mm. Variation limit plus 5 mm minus 5 mm. Steel used for LPG cylinder shall conform to IS 6240 2008. It all starts with receiving the hot rolled coil as per delivery challan and test certificate as per standard IS 6240. Test certificate is used to verify the cast number and coil number. As we begin, put up HR coil on the decoiler for straightening. It's important to inspect the coil for thickness and width. Circles are cut from the coil as per the capacity of cylinders, and each circle is color-coded for identification purposes. Carry an inspection to detect the flaws in circles like burr, scratches, pits, line mark, lamination and more. Soon after, measure the dimensions of the circle in terms of thickness and diameter. After circle cutting, halves are drawn by pressing a circle in a hydraulic power press. It's important to apply DD compounds on each circle to avoid scratches, pits, line marks and carbon. In the next phase, uneven edges of halves are trimmed by a trimmer cutter on a trimming machine. It's crucial to maintain a specific height as per the company's requirement. After trimming, bunghole punching is made on the halves by power press or mechanical power press. Diameter of bunghole should be 52 plus minus 0.3 mm for all capacities. Clean the halves with hot water and caustic soda under a temperature of 80 degrees Celsius in a conveyorized system. This process is followed for removing oil, dust, carbon particles, etc. After cleaning the halves, check for defects like wrinkles, pits, scratches and line marks. Check for specified height, ID, OD, minimum wall thickness, bunghole eccentricity and color code of each halves for traceability of heat number. Now for bung welding of upper halves. It will be done by metal inert gas welding process with argon 92% and carbon dioxide 8%. Diameter of the copper-coated mild steel wire will be 1.2 mm. a bung weld inspection should be carried out to find defects like pinhole, blowholes, undercut, incomplete welding, burnout and welding profile. The foot ring welding of bottom halves by MIG welding process with an equi space of 6 numbers of welding runs as per the oil company's requirement. A visual inspection is carried out to find defects like spatters, pinhole, blowhole, incomplete welding and foot ring out. In a joggling machine, top halves will be formed. Joggling length will be 9 plus or minus 1 millimeter. Next up is buffing of top and bottom halves for cleaning the surface for welding. Next process includes the assembly of the top and bottom halves by a pneumatic operated fixture to form a capsule. The procedure of buffing the circumferential area of the welding joint will be followed later. For the circumferential welding cylinder by twin wire MIG welding process, the current, voltage and revolution time of circumferential welding needs to be as per requirement. Diameter of the CCMS wire should be 1.2 millimeters. Machine number will be punched on the foot ring of each cylinder for identification. Under the inspection of C welding, defects such as pinhole, blowhole, undercut, uneven welding, burnout, welding profile and welding overlap joint will be inspected. Hand welding of the valve protection ring on the cylinder's body is done by MIG welding process, both inside and outside. Now begins the stamping process. Serial number, body raw material, identification and test date are stamped on the bung. Note that the serial number on the stay plate and bung should be the same. After welding the foot ring, VP ring with a stay plate, the cylinder will be inspected for all the welding defects, cylinder height and record. The cylinders passing this inspection will be sent further for the heat treatment. All the cylinders are heat treated for relieving the stress. To load the cylinders, the furnace is oil and LPG fired continuous type with 2 rows to load cylinders. The parameters of heat treatment includes a soaking temperature of 680 degrees Celsius plus or minus 20 degrees Celsius. Furnace process time as per the capacity of cylinder to be furnaced with heat treatment. All the cylinders are cleaned from inside by vacuum to remove the scale. Soon after the heat treatment, all the cylinders are tested for hydrostatic test on hydrostatic test station. The testing station is equipped with an auto water filling and evacuating pump and a high pressure pump to attend the test pressure of 25 kg force per square centimeter with an illumination from the bottom side by a mirror. For the hydrostatic test parameters, the test pressure should be 25 kg force per square centimeter. Test duration under the test pressure should not be less than 30 seconds. There should be no leak from the cylinder body or weld joints. Also, no reduction in the test pressure. Please note that the test results will always be recorded. The bung hole is now blocked with a plastic cap to prevent grits from entering the cylinder. Cylinders are now loaded on the conveyor of the grit blasting machine horizontally. The iron grits are blasted on cylinders centrifugally to remove outside scales. After this, the grit blasted cylinder will have a clean rough surface of 2.5 SA specification. A zinc metallizing operation is carried out as per the specification to protect the surface of the cylinder from corrosion. The operation includes zinc wire spray metallizing by a metallizing gun. To obtain metallizing thickness of minimum 40 micron on cylinder surface, rotational time of cylinder and wire melting speed is controlled. To melt zinc wire, a mixture of oxygen gas and LPG gas is used. And for feeding the zinc wire in a metallizing gun, air pressure is used. In this process, a zinc wire of 3.15 mm diameter of IS 12447 standard is used. While painting, the cylinder is rotated on a conveyor with a hanger in the primer painting booth. The paint is sprayed in a way to obtain not less than 15 microns thickness all over the primer painted surface of the cylinder. The paint dries after going into the oven at approximately 80 degrees Celsius. Total coating thickness of zinc, primer and paint should not be less than 67 microns when measured with a coat meter or as per customer requirement. Now, the shroud will be painted with the company's specific colors by a hand brush. On a specified stay plate, the process of stenciling the retest date will take place with a specified color. It's painted from inside with a specified color as background and of specified dimensions of figures. Now it's time for stenciling safety slogans and net weight at the specified location with a color matching the company's logo. An operation for bung thread inspection and internal cleaning includes: Step 1. Bung thread cleaning by a 3/4 inch NGT finishing tab and checking by L1 and L9 thread gauges. Step 2. Cloth cleaning to remove water traces. Step 3. Vacuum cleaning to remove scales, water traces and foreign particles from the cylinder. Step 4. Hot air drying by hot air blower. The cylinder's internal cleaning inspection is carried out with a low voltage bulb fixed on an extended rod. Visual checking is performed after inspecting the cylinder. To carry out the procedure of tare weight weighing with barcode, use an electronic weighing machine. Like, the capacity should be 0 to 60 kg with a least count of 5 grams. It should be daily calibrated with 1 kg, 5 kg, 10 kg, 20 kg weights before weighing. The tare weights are rounded off as per the specification of IS2. Tare weight is measured along with SC valve and safety cap. Finally, batch-wise and serial number-wise, tare weight computerized barcode is generated. The next process after weighing the tare weight is tare weight stenciling. It's done at specified locations in a predefined size and color as per the company's design. After the tare weight stenciling, the weight is stamped on a stay plate at a specified location with a specified figure size by hand punches. This happens after locating the stay plate and cylinder on the fixture horizontally. Tare weights are also punched on bung. SC valves are kept in secured place and custody. Valve threads duly wrapped with 2 to 3 rounds of Teflon tape of 3 to 4 inch width and 40 microns thickness are then hand tightened in the bung of the cylinder. Such cylinders are taken for SC valve tightening on auto hydro torque tightening machine with preset torque value of 145 plus minus 15 pound-feet. The torque exerting spindle stops automatically after attending specified torque. The torque can be later measured by a duly calibrated torque wrench. After the SC valve fitting, refrigerated compressed dry air is filled with a filling adapter. During this process, air pressure in the cylinder is kept at 12 kg force per square centimeter. And after the air is filled, cylinders get ready for pneumatic leakage testing. Now comes the pneumatic leakage testing. Step 1. The pneumatic leakage test is carried out only after confirming the test pressure. Step 2. Such cylinders are then immersed in the clean water tank for 1 minute, duly illuminated from outside and inside of the testing unit. Step 3. After the standstill condition of water, the cylinders are kept immersed in the water tank by a pneumatically operated cylinder, holding the fixtures for 1 minute. Step 4. Cylinders that successfully pass the test are sent for air evacuation and further operations. Cylinders that get an OK from pneumatic leakage tests are then taken for air evacuation. The operation is carried out with the help of air regulators. Here's the final inspection. After the air evacuation process, cylinders are inspected for any defect of stenciling or other visual defects and scanning barcode after pneumatic. Such approved cylinders are then stacked batch-wise for BIS inspection and certification. Cylinders are randomly drawn for performing acceptance tests and burst tests. The same is carried out by a third-party inspection agency. In our final stage, after the verification of test records and certification of the batches of cylinders by IOBIS, we arrange to dispatch the cylinders. They are wrapped with corrugated paper and sent to the respective plants by trucks. The components of a cylinder are MS bung, top ring, stay plate, foot ring, and SC valves.